Right, so we have this curve here. You've never seen anything like this. You've never had to graph anything like this, at least not with me. Um, I will give you a quick, this is about what it looks like. It's kind of, it's kind of parabolic-ish, and it kind of does something like that, and it curves away, and whatever. But what we know is that the point 0, 1, and 0, -1 are on this curve, and we can do that. We can figure that out. I'll just write them down, 0, 1, and 0, -1. We could just plug them in and see that directly. So if we plug in x equals 0, this term becomes 0, this term becomes 0. So y squared equals 1. There's two solutions for that, 1 and -1. My question is what is the equation of the line tangent to each one of these points, right? And we're going to do that even though this isn't a function. The process is really, really similar. So the first thing I'm going to do is I'm going to take the derivative with respect to x of this whole thing. Now, the derivative of y squared with respect to x is 2y dy dx. Don't forget the dy dx. Next, we need to take the derivative of this thing, but we should look at it and go, ooh, product rule. That's going to be important. So we got to pay attention to all the rules. So I'm going to break this up as 5x and then y. There's lots of ways you could view it, though. So the derivative of 5x with respect to x is 5 times the derivative of x. We're going to write dx just for the sake of the habit of it. And then I'm going to, so that's the derivative of the first times the second plus the derivative of the second. The derivative of y is dy dx times the first, 5x, plus the derivative of x squared is 2x dx dx, and the derivative of 1 is 0. So we have all that derivative. Now we're going to start simplifying. What I see is that we've got this dy dx that we need to solve for and this dy dx that we need to solve for. These two are just 1, so I'm going to ignore those. And I'm going to solve for dy dx. So step 1 is move everything that's not dy dx to the other side via subtraction or addition. So what I have left on this side is 2y dy dx, that's this term. I got 5x dy dx plus 5x dy dx, that's that term. And I'm going to say it equals -5y minus 5y, and it also equals -2x minus 2x. I don't know why I underlined it. There we go. Okay. So I moved all pieces that didn't have dy dx to the right, and I kept dy dx here. Here's the key. This is probably the newest bit of algebra that you need to do, and probably the trickiest if you haven't seen it before. At this point, I just need to factor out a dy dx. So I say dy dx times what thing will give me this? Well, the answer is going to be 2y plus 5x. And it still equals -5y minus 2x. My last step is I'm going to divide by this whole thing. So I have dy dx is -5y, not plus, minus 2y over 2y plus 5x, 2y plus 5x. This tells me the slope at any point on my curve. So now I need to find the slope of each one of these points, right? And so I'm just going to plug in 0, 1. So when I plug in 0, whoops, minus 2x. When I plug in 0, this turns into 0, this turns into 0, and this and this turn into 0. So I end up with -5 over 2 for my slope. Equals -5 over 2. If I plug in 0, -1, These two terms are 0, so I don't need to worry about those. I'm not canceling them out. They are 0. Get rid of that thing so you don't think I did. And then I plug in -1, so I should get a m equals positive 5/2. And you've done this many times. You need to write the slope of, or the equation of a tangent line. You just do y minus y1 equals m times x minus x1. I don't need that 0, but it's nice just to have the habit of it. And I do it again, y minus y minus y1. Notice I just do the double negatives, again, just so I don't make mistakes, equals 5/2 x minus x1. And I could totally simplify those, but those are perfect answers. Thanks. Good luck.